Alright, so this is the second recording of the series. The first one, we talked about loading the data and installing the packages and loading the packages. In this one, we're going to just go into more elementary basics. For example, names, use a summary function, cells, replace. So I wrote a little comment over here describing like the variables and then seeing the names. So you know that we have employment, revenue, EBITDA, BQ growth score, BQ risk score, profit score, whatnot. And as we can see, go to DF1, all the names are there. We want to see the dimensions. So dimensions of DF1, it is a 10,393 observation by 42 variables name. And if we want to dig into the structure of it, we do str df1. So what this does, it tells you first off, this is a data frame of 10,393 observations like before with 42 variables. Then the first variable, which is indicated by the $, extract, then the first variable, PQ company legal name, it shows that it is a factor with 10,393 levels, meaning that each name is independent. And the fact that you have 10,393 observations here and 10,393 levels means that each level corresponds to a name. So over here, you have 1,001 levels. That means that you're going to have probably like 1,001 names within there that are not NA. So there's probably, during the collection process, people filled in about 1,000 of the parent company. Then industry name, you have 105 levels. Business codes are just numbers, but they should be transformed into a factor, which I'll show you how to do that later today. The subject of industry, you got all these random numbers. Contact name, so this will be interesting, and we'll drill a little bit deeper into this. Some of the stuff like name, question mark, or OL con. And so this just shows the structure of it. And we'll be cleaning some of it, and we'll be getting rid of some of these. But this is just a little investigation into it as to what is the structure of each column and what do you need to change. So looking at this, we're not going to be using many of these, so tell it to extract the columns. So remember your Excel sheet, your pseudo Excel sheet in R, this thing. So again, we are interested in these variables, and we care little for like parent or at least in my analysis, I care little for parent company and like BQ business code and subjective industry, so I'm going to get rid of them. So I'm going to tell R to create a new data frame, store all this into data frame called df 1.5, and on the left side of this comma, if I don't put anything, I'm telling it to get all the rows, but if I do put something, I'm telling it to get the first row or the second row. And then over here, I put the columns. If you want to give R a vector of numbers, you have to put it in this format. So like C, 1, 3, 5, 6. And then over here, you see these semicolons. I'm telling it to do 35 all the way to 37. So right now I'm telling it to extract the first column, the third column, the 15th column, 17 to 29th column, 35 to 37, and 40 to 44. This is the old-fashioned way. What happened here? Dimensions, df1, there should be 42. Oh, I know what's wrong. Forgot. In the original script, I added these just for fun. So going back here, add these. So what I did over here was I told it to go to df1 and create a new column called rev.emp, and that in it is the revenue from df1 divided by the BQ current employee plan of df1. And remember, R is very case sensitive, so you gotta be very you gotta nail it on the head. So, but luckily, if you do like df1 extract, it'll show you all the different columns that are available. So run these, go down here. I'm telling the df 1.5 to just have these. Alternatively, because I know this isn't really aesthetically pleasing, you can go and you could use a function from the spelling dplyr wrong. Okay, I think spell this way. From a dplyr function package. So you can do the same thing, and this will be the way that it's structured. So select your data frame, and then the names of what you want. Let's try it out. What's going on here? Oh, I know what's wrong. So df 1.4 gets select df1. Actually, I should do this. df1, and you pipe it into select. Okay, so you have the data frame 1, and you're telling it to run this function on data frame 1. So instead of writing it like this, and I want to select what are some of the names here, the names of df1. I want it to get this and this. You don't need to put it in quotes. Library, dplyr. Cool. Now let's view df 1.4. Boom, it already has it. Alternatively, so what we wanted was company legal name, not parent company. We wanted BQ industry name. Let's put that in there. Let's see, 1, 3, and 15. We want our website. Get rid of these quotations. And then we wanted like this entire shebang from like 17 to 29. So we could just get this, and then here, let me put it in here. So I'm telling it to go from the current employee plan and with a semicolon all the way to the employment growth rate. Again, this can only be done because of the select function from dplyr. So this is telling R to get the columns from employee plan all the way to employee growth rate. And then if I want to take it home with global.rank all the way to country.rank, and then just take it home with web creation year all the way to profit.margin. Let's view df 1.4, and we can see the Excel, well, not Excel sheet, but like kind of like the data frame sheet that we created. And let's check. df 1.4 is equal to df 1.5. well, for the most part, it's true. The reason why you have some NAs in here is because NAs are a little bit tricky. It won't let you know if something is equal to an NA. But bottom line, these two are the same. You could do these in the exact same way. The difference here is that the numbers might change. Here you're using numbers as placeholders. So if you move around the columns, you might not necessarily get the same thing, but here the column names are the placeholders. Well, anyway, end of that side note. I'm going to comment these. Or I'll just leave it for you guys. Last thing I want to kind of cover in this video is, now that you have the data set in and now that you can select which ones you want to work with, just want to quickly take a look at the data and see what's going on. So we run a little summary on it. So the summary function gives you a quick summary of every single column. And that's where the structure of the columns comes into play. Because if it's an integer, it'll give you something like this, a little distribution of the max and min. And if it's a character, it'll give you, well, like the legal name, or like how many of that characters or factors are there. So in this case, in industry name, we have 539 advertising, 509 in commercial banking, 411 and other information services, 374 and whatever, and 7777 another. And then over here you can see that the First United Bank website is repeated 6 times. Performance trust is repeated 3 times. This is repeated twice in there. So it's prone to investigation. When I originally cleaned the data, there were different companies with the same website. I didn't know what to make of it because I wanted to do the most objective cleaning, so I just left it as is. But it's a really quick fix, which we'll do later on. And before we get there, just quick look at employee plan. So over here looks kind of skewed. If the median is 359 and the mean is 1,314, and you can kind of see that because of this really large number. If you want to quickly take a look at it, run histogram of DF. What is this? Is this 1.5 or? Okay, this is 1.5. And I want the PQ current employee plan. Boom. Okay, this is not